The following session will be dealing with a display device called a 7-segment display, which consists of 7 segments and a decimal point. These segments are illuminated from inside with the help of LEDs arranged in the form of an array. The displays can be used for interpreting numbers and few alphabets, primarily used for hexadecimal displays. So the results of the practicals will be displayed by using either one 7-segment display or a combination of multiple 7-segment displays. For example, an 8-bit number would need to be interpreted by using two 7-segment displays, and a 16-bit number can be displayed by using 4 7-segment displays, as these numbers are depicted through hexadecimal numbers. Looking at the internal arrangement, we get to see that there are 8 LEDs representing these segments, which are labeled in a universal pattern by name A, B, C, D, E, F, G and H, representing a decimal point. So the LEDs which are inside will also be labeled accordingly with the respective segment names called as A, B, C to H. Looking at the arrangement of anode and cathode, we get to see here that all the LEDs anodes are connected together for a common point, and the cathodes are individually driven so that the LED can be controlled. Each of these LEDs are also identified with the respective segment names, which corresponds to the respective segment in the panel, hence the name A to H. The hardware setup indicates that the LEDs are driven through a current sinking arrangement. These cathodes are driven by the driving device. Here in our case, it could be a microcontroller or a microprocessor. Driving a 0 to individual LEDs will be turning them on, and driving the LEDs with 1 on the cathodes will keep the LEDs off. To display the digit 0, we will be displaying only LEDs, or we will be illuminating only those LEDs which represent the segments of 0. Here in 0 displays, we get to see that segment A, B, C, D, E and F remains on, and G and H in our case need not be turned on. And hence the representation zeros on all these segments will make these pattern displayed, and G and H will remain off with 1 driven from the driving device. When it comes to display 1, we get to see that these are the segments representing 1, and then B and C are the LEDs which need to be turned on. So controller need to drive 0 on segments B and C, which will be taken to these two LEDs, and that justifies why zeros need to be ported through B and C, and the rest of the segments are representing 1. Likewise, for displaying the digit 2, these are the required patterns or segments which need to be illuminated, and we get to see that these respective lines are to be driven with 0, and the rest of the segments which need to be remained off is F, C and H. So these are the data which need to be ported through the respective port lines of the controller. Likewise, we would be able to display digits 3, 4, 5, 6, 7, 8, 9 and also alphabets of A, B, C, D, E and F that will also be used for displaying hexadecimal numbers. There are primarily 2 types of 7-segment displays which are fabricated, which are in common anode connections and common cathode connections. Referring to the previous arrangement, we got to see that was wired in a common anode setup, where all the anodes of the LEDs are connected together to a common point, which could be VCC, and the segment drives should be driven with appropriate lower voltage, which will display the respective segment. There is another category of fabrication of 7-segment displays where all the cathodes are connected together to a common point, and that the favoring voltage should be a ground, and the driving the segments need to be driven through a higher voltage, which would be transported from the driving device, which is a controller. Hence, ones on those lines will be illuminating that, and zeros will be switching off the LED. So there are 2 kinds of 7-segment displays available. One referred as common anode and the second one referred as common cathode based on the internal wiring arrangement adopted. So here the complements are used for driving the common cathode arrangement when we are referring it with the voltages from the controller. For displaying the segments, we will have to drive appropriate voltage on the segment level. Segment C of a common anode will be illuminated when you keep a C segment or C port line will be grounded. Here in common cathode setup, the port line need to be connected to a higher voltage, which is VCC or a digital one. Likewise, individually the segments, if it needs to be driven, the arrangements need to be appropriately driven. We get to see that there is a unique pattern of ones and zeros which need to be driven on the segment lines, which will end up displaying the respective digits as intended, which is 0, 1, 2 or hexadecimal representations of A, B, C, D, E, F. All that need to be driven with appropriate binary values. Realize that these values are going to come from the controller's port line. So if this 8-bit number, if it has to be transported to the controller's ports, the programmer need to provide it in the form of the respective combinations, which is interpreted in hexadecimal values. So the 3F, which is depicted in this particular table, is used for displaying 0 on the 7-segment displays, which eventually will transport a series of ones which will drive the segments A to F, and G and H remains off with the help of zeros, and that is what is demanded for displaying the digit 0. Likewise, when it comes to digit 1, we need to see this, that 06 is what the programmer would be transporting through the port line, which will be decoded in binary in the form of all 4 zeros in the upper nibble and 2 zeros on segment D and A, and 1 to be driven on B and C. Because that's what is expected for digit displays of 1, that segment B and C should be illuminated, and the programmer need to generate a value 06 as a hexadecimal 8-bit number. So in the program, if we are expected to display 1, we would be displaying, or we would be transporting rather 06 on the port line, 5B for 2, 4F for 3, 66 for 4 likewise. Remember, all of these 8-bit numbers are to be interpreted in the form of a binary number, and that binary digits are going to drive the respective segments, which will eventually end up displaying the characters as desired.